Okay, so the second half of the lecture for today did not get recorded. So I'm going to repeat that now. We did 2 examples. They were pretty, let's say, the hardest examples we've had. So I will repeat those examples now for the benefit of people who didn't catch the lecture today. So the first problem that we did after the break was problem 5.12. Let me get the whiteboard back up. Not that whiteboard. So we're doing 3,000 problems 5.12. This problem says a ball is thrown upward at an angle of 30 degrees to the horizontal and lands on the top edge of a building that is 20 meters away. The top edge is 5 meters above the throwing point. How fast is the ball thrown? So it's thrown up at an angle and it lands on top of a building. This angle is 30 degrees and we're going to have a path that does something like that. So that it's the distance above its start is 5 meters. And the horizontal distance away is 20 meters. And we want to know what is the initial speed. So translating, we know delta x equals 20 meters, delta y equals 5 meters, ax equals 0, ay equals negative g, theta equals 30 degrees, and v initial equals question mark. So we have multiple avenues. What I discussed during the lecture was that we have, essentially every single equation has the initial in it. So we have to kind of look at what we know. We know delta x and delta y, those are given. So I want to pick one of those equations to work with. And I chose the delta y equation, although maybe delta x equation would have been easier. I chose the delta y equation. So delta y equals v initial y t plus 1/2 ay t squared. And we know v initial y would be vi sine of theta. And we can replace ay with negative g and merge that with the 1/2 to get minus g over 2. And I forgot my t on vi sine of theta t. Okay, and then if we check what we know delta y, and we know theta, and we know g. So this tells us we have to find t. So then we can go to our delta x equation. The delta x equation, let's just use that here. Delta x is v initial cosine of theta times t, or in other words, vix times t. And so t would be delta x over vi cosine of theta. So one of the things I commented on in the lecture was we had a question on the previous problem that said, well, couldn't we just get a number for t and plug it in? And in this case, we're following exactly the same route, but we could not get a number for t because we don't know v initial. We're looking for v initial. So in order to solve, we really need to do the algebra this time. Just going to move my delta y equation down. We have delta y equals vi sine of theta times my expression for t minus g over 2 times my expression for t squared. So I need to fill in my expression for t. That's delta x over vi cosine of theta. And we can see that we're going in exactly the same route. The vi's cancel over here. And we're going to get delta x tangent of theta minus g over 2 times delta x squared over vi squared cosine squared of theta. And if we check what we know delta y, and we know delta x, and we know theta, and we know g, and we know delta x there, we know cosine of theta. So we have everything in here that we need in order to find v initial. So the name of the game is just to do algebra. Now, of course, you could plug in numbers and then solve, but we're trying to get stronger. So we will do the algebra first. And the algebra is always take whatever's not attached to my variable. My variable's vi, so the piece that's not attached is delta x tangent of theta. And we want to move that to the other side. So we get delta y minus delta x tangent of theta equals minus g delta x squared over 2 v initial squared cosine squared of theta. And there's not really a unique way to do this, but for me, what I suggest is I don't like that the variable I'm looking for is in the denominator. So I'm going to multiply both sides by v initial squared. V initial squared times delta y minus delta x tangent of theta equals negative g delta x squared over 2 cosine squared of theta. So finally, I have the v initial squared on the left, and it's being multiplied by some stuff. So I want to get rid of that stuff by dividing. And we have vi squared equals minus g delta x squared over 2 cosine squared of theta. And here's where, when I divide by delta y minus x, delta x tangent of theta, it goes in the denominator here. So that's my expression. And I can just plug those in. So I'll copy it and move it to another page. And our v initial is the square root of all of this stuff. So minus, let's see, we are working in the English, or in the metric unit, so our g is 9.8, and our delta x was 20 meters. Then we have 2 times cosine squared of 30 times delta y, which is 5, minus 20 tangent of 30. And I'll just kind of cheat and peek back at what our answer was in the previous case, we got 19.98 meters per second. Okay, so that's problem 5.12. And the key thing here is we wound up having to get to the same expression as the previous problem, but plugging in numbers would not have worked this time. We really need to be able to work with the algebra. Now, when you're solving problems on a contest, you may well want to plug in numbers a little sooner to save you time, if you sense that it's going to save you a lot of time. But when you're practicing at home, you're at the gym, you're working out, and your goal when you're working out is not to have an easy workout, it's to have a hard workout, so that when you get to the contest, you're strong and you're fit and you're fast and agile. You want to be strong when you get to the contest. So the next problem is going to really tax your strength. This is 5.18. You might want to get some coffee before you watch this one. So this problem doesn't necessarily have to be super hard, but we worked it out with symbols, and I picked, for variety, maybe not the optimum equation to start with, to show that you can pick any equation you want. Now, it wound up being more work than maybe it was worth but maybe not, because it definitely is a good workout. So we have a picture of an object being thrown off of a building, and it's going to hit another building. Its path is going to look, we don't know, because we don't really know where it hits on the building. The problem actually says to, how far above or below its original level will the ball strike the opposite wall. So we have this original level, and we're being asked for delta y. It could be a negative number below, or it could be up here somewhere. And the individual numbers that are given is, we have 20 feet per second for the initial velocity, and an angle of 40 degrees, and a distance between the buildings of 50 feet. And so if we translate all of this information, we know that delta x equals 50 feet, v initial equals 20 feet per second, theta equals 40 degrees, ax equals 0, ay equals negative g, and delta y is what we're looking for. So this is basically all of the same information that we have had in the last, or two problems ago, where we don't know VFX or VFY or T, and we wanted to find delta Y. So we could follow that route. So what I did is I said, what if we chose a different equation? And the first time we did the delta Y equation. So what if we pick VFY squared equals VIY squared plus 2 AY delta Y. If we pick that, we know VIY in principle because we know VI and theta, and we know AY, and this tells us we have to find VFY. So no problem. We have an equation for VFY. VFY equals VIY plus AY T. So we can find VFY as long as we know VIY, which we do, and AY, which we do, and T, which we do not. So, no problem. Let's find T. And what I did is I went back and looked at the main equations, and I pointed out that we only have, we've used these two equations. This green line is to indicate we've used these two equations. And so we have two more equations that have t involved, and we could try either the delta y equation or the delta x equation. Delta y is going to take us down a wrong path because eventually we've made a circle and we discover something like delta y equals delta y. It tells us a true statement, but it doesn't give us a number, okay? And that's because we actually need to know how far away the building is to answer the question. So we're going to pick the delta x equation. So my delta x equation equals v initial x cosine of theta, or sorry, the cosine of theta is in the v initial x. So v initial x times t, which would be vi cosine of theta t. And, you know, we know all of those things, so in principle, we can find t. Our value for t is delta x over vi cosine of theta. Now, this is what we've done already. We could solve this for t and get a number and work our way back up, but for some reason, okay, I'm going to admit it, I probably shouldn't have picked this method. This winds up being very long if we go symbolically, but it is good for the soul. So we find that VFY equals VIY plus AY times T. And that means it's VI sine of theta minus G times VI. Okay, let's see, G times delta X over VI cosine of theta. So I'm taking this value for T and putting it in here. Okay, now where it gets tricky is I have to take this expression and substitute it here and square it. That's why this becomes pretty bad. So let's move to a new page. Copy over that equation. VFY squared equals VIY squared. Instead of VIY, let's put VI squared sine squared of theta plus 2 times minus G times delta Y. And for VF, we're going to put in our expression from the previous page. VI sine of theta minus G delta X over VI cosine of theta. Let's make sure that's right. G delta X over VI cosine of theta. And then we have to square that. And that's equal to VI squared sine squared of theta minus 2G delta Y. So there's different ways we could do this. I suggested rearranging the original equation in class and solving for delta Y first. This time I'm taking a slightly different approach. If I FOIL this, let me remind you, if you have a minus b squared, that's going to be a squared minus 2ab plus b squared. That's what happens when you FOIL to square something. So this would be vi squared sine squared of theta minus 2 times vi sine of theta times g delta x over vi cosine of theta, and then plus g squared delta x squared over vi squared cosine squared of theta. So we just fill in the right-hand side, it doesn't change. Then we start to simplify because we can see that the same term is on the left and the right. Additionally, we have VI over VI, and we're going to see a sine over cosine. So it's going to start looking more familiar. We have a minus 2 g delta x tangent of theta plus g squared delta x squared over vi squared cosine of square root of theta equals minus 2g delta y. Now there's a g on every term, so I can cancel 1g. And then I just have to divide by minus 2 to get delta y. So delta y equals delta x tangent of theta. Let me show you. Divide by minus 2. Okay. And that gives us a minus g delta x squared over 2 vi squared cosine squared of theta. So this brings us back to that same formula that we've seen in the last 3 problems. And we can plug in our numbers. So we have 50 times the tangent of 40 minus 32. So since we're using feet, my g has to be in feet per second squared, which is 32, instead of meters per second squared. Then we have delta x squared over 2 times, what was my v initial? V initial is 20, so 20 squared times cosine squared of 40. And again, I'll go back and look at what my final answer was. It was negative 128 feet. So we might say 128 feet below the starting point. Or below the starting height. Okay, so that was a little bit actually shorter than the one version I did in class, maybe, in terms of number of pages or number of lines. But still, you can see this is really intense. Okay, now don't drop the class because you don't want to do a problem like this. You would never work this out the hard way on the exam. You will use numbers and simplify things sooner. This is really just for practice because the harder we work out mentally before the contest, the easier the contest goes. Okay, so that is what was missed. Now, my recommendation for, and was without pauses for questions. My recommendation is finish up your work tonight, and that way you can come to class tomorrow or send me emails tomorrow with questions about whatever homework you're still struggling with, and you'll have a good day to really practice and hone your skills and get ready for the contest. Tomorrow, I will give an introduction to Chapter 4, but it will not be a really formula-heavy lecture because I know you don't really want to learn new stuff yet when you're still studying for the contest, but it will give us the concepts in the background of our mind so that after the contest you're ready to start mentally changing gears. All right, thank you.